Assalamualaikum, very good day. Welcome back to mechanism design. And today's topic will be on forward kinematics and inverse kinematics and how they relate to ultimately robot kinematics. Okay, let me share my screen. I hope you can see this screen. And let's start from the beginning. So this is a topic that is shared by both the MKU 4363 as well as the graduate class graduate course MMCD 5813, which is computer aided engineering. So if you have taken this in your senior year, I guess if you continue to do masters at UTM, it'll be something easier for you to pass. And, although it's not given an exemption, but it is something that should be easier if you see it for the second time and easier for you to pass with flying colors. So robot kinematics is part of the focus that will be in the test, but the actual topic being covered here is called forward and inverse kinematics. So robot is just part of or an example of kinematics, special kind of mechanism, linkage mechanism, but it has some differences in the way that a robot is something programmable, and usually it has a robust and more flexibility in terms of its capability to do more than one task. So usually it's not made for just one task or task, and it is something that is capable of doing multiple tasks, maybe with some little modification, maybe usually in the n effector, and then we have to reprogram it to be able to do another task. Okay, whereas for the regular conventional linkage mechanism, usually if we design it to do certain things or certain parameters, we can only be doing that task. If we change it to some other task or some other reach, or maybe you want to go beyond the original reach, you cannot do that anymore. So that's the difference about between robot and regular linkage mechanism. All right, so the most famous linkage mechanism would be the one that you can see on the in the red one, red color here. So it's something maybe it has the capability to move from one place to another, but as you can see in this here, we have one big link or one big joint over here, and another joint here, another joint here. So this we say it has 1 to 3 revolute joint or R joints. So R joints. Usually in the R joints, there'll be motor, electric motor that will enable to control the links next to it. Okay, but there are a lot of other kind of robots, such as in aircraft, they have robots that will help pilots to navigate, especially when it is cruising in the air, about 30,000 feet in the air. And nowadays we also have autonomous cars, like I think the one in the picture here is called Waymo, and it's operating in California. Anybody has been to California? But I have seen some other examples in China. They also have bus, also taxi like this, that is driverless, so operated by robot autonomously. And we also have this cleaning device that can go in the mall or in the airport. I have seen this kind of machine operating in KLIA. So now big airport, they already start to use this kind of robot to do the cleaning. All right. So what do we mean by forward kinematics? So forward kinematics is that when we give the information such as theta 1 and also theta 2, theta 1 and theta 2, we will be able to know what is the coordinate of the end effector or the gripper here, the gripper. So once you know the coordinate of the end effector, so meaning you know this will be the input theta 1 and theta 2, and if you see here, because we treat it a bit different from before, where in the past or in the previous topics, the angles are absolute. So we measure the angles exactly from the positive y-axis, positive x-axis, okay, or pointing to the east, pandang timur. So pointing to the east is 0. So and then if we go clockwise, counterclockwise, that angle will be positive angle. If you go clockwise, that angle is a negative angle. Okay. So, but here in this topic, we use not absolute angle, but rather relative angle. Relative angle, meaning if theta 1 will be referred to, or the reference plane or line will be the horizontal line. But theta 2, the reference line will be based on the link of link number 1. So that is based on the previous link. So theta 2 is based on the previous link, which is link 1. Okay, and then if you have theta 3, will be based on the link number previous link, which is link 2. All right. Whereas for inverse kinematics, it is opposite. We are given the coordinate of the x and y of the gripper. Then we want to know, or when we want to find what the angles that will allow that to happen, which is theta. We want to find theta 1, theta 2, and so on. So this is an example for uh, the use of robotics, maybe tele uh, control by operator away from that site. So here, even the truck is driven by operator outside, or maybe it is autonomous. Not so sure. But also for the excavator is also teleoperated. So this is made possible by having a good communication network, like 5G, 6G, and so all these things will enable this kind of technology to be utilized. Okay, so this David Hartenberg is two professors who pioneered this the study of robotics, especially in America. I think they were both based in Chicago, uh, and DH or David Hartenberg is a very popular concept that is usually taught in basic courses of robotics. Okay, but for our purpose, we are not going to deal or dwell on those kind of things. But if you are interested, feel free to find more information about David Hartenberg. But as far as we are concerned, we can look into closed chain and also open chain. And for each of them, we look into what we mean in terms of forward kinematics and inverse kinematics for both types of chains. Okay. Okay. And in this 4-bar mechanism, you see you have this the maybe point A. I should label it A, B, C. Maybe I can still do that here. I can use my glasses back. So if I have point A here, B, and C, D, maybe point O here. So that is the origin. So we basically have to go through from the origin to point A, B, and C. And just like before, that is the first route. And to get to point C, we can also have another route where we can go from O, A, D, and C. Okay, so that's another way. So the two routes can be utilized here. And we can use this what called homogeneous transformation matrix. So here we have a bunch, but we can, so that is depending on a bunch of rotational metrics or matrices. Okay, so this kind of rotational matrix, so this one involves rotation with the angle theta 1. And over here is translation. So this is actually going from the origin 0, 0 to point A. So this is going to point A, and also at the same time we turn it from this x naught or x0 to x1. Okay, that is the operation that we are seeing here in this first box or first matrix. Okay, the second matrix, okay, the operation, the rotation is about point Z or Z. So it's not rotating about X, not rotating about Y, but about Z or Z. Okay, the second operation is to get from point B, A to B, A to B. But I guess this is not, this is just rotating along by theta 2, rotating by theta 2. So this theta. So from theta 1, rotate to get to theta 2 or x2. So this is x1. So by having the next rotation by theta 2, we get the frame, this frame to x2. So this is x0. This is x. We bring to x0, then x1, then x2. So x2 is the rotation still at point A. It's not translating yet. So by theta 2. And the next operation is that you have translation by A in the x direction. And we have, after translation, we rotate it by theta 3. Okay, so we have this rotation and also translation in the x direction. And lastly, since you have already rotated by theta 3 into this x3, so the last one to get here, x4, is just slide or translate along x direction by the amount of h. So that will get you to point C, and the frame will look like that. And that is from using the first route. Second route, this one will get you from origin to point A, which is at UB, and then translate it exactly just like on top here in the first route. So after that, you translate along X by G, and then rotate by theta 4. So translate here along X by this amount, G, you get here, X5, and then rotate to get to X6 by theta 4. Okay, and then from there, you just translate B, and also there's a rotation by theta 5. Okay, translate around along here by this much, B. Okay, you get to this position. And then from theta, from this one, you rotate it by theta 5 and get to x7 here. Okay. So this, you can, for each of this route, route 1 and route 2, you can multiply them out or expand them And to do the calculation, you go from the right to left. So this one you have to calculate or multiply this and this first, and then this and the new one, and then lastly the first one with the new one, the new 3 by 3 matrix. Okay, same here. So multiply this one with this one first, you get another 3 by 3. Then this one with the new 3 by 3. Okay, so you'll get this one, and from there you can get this conclusion, where if you want to find xy of the smiley here, or point C, x will be this thing, so and y will be this thing. So see, there are two equal signs here. So this one will be using the first route. This one will be the second route. So you can use either one way. All right. So, but if you follow first route and second route, the answer will be slightly different, but very close. So this is the theoretical value. If you draw it by CAD using all the information, x and y will be this much, and then if you use this equation, the result will be a little bit different. This one is using route A, and this one will be using the second route. So there is some differences there. So that is forward kinematics. So next is the inverse kinematics for closed chain. So in this case, we know the coordinate of the Smiley, which is this 165, 153. Okay, we want to find what are the thetas, theta 1, 2, 3, 4, 5, whatnot. So in this case, I guess theta 1 is already given. So you can find what theta 2 is, theta 4, and theta 3 and theta 5. Can calculate. So unit theta 3, theta 5, if you go route number 2, route number 1 would be using theta 2 and theta 4. All right, so that's it for closed chain. You can cover the open the forward kinematics as well as the inverse kinematics. For for open chain, meaning it's like for the robots. For the robots, here we have link number 1, link number 2, and then link number 3, which is all together with the frame here. Okay, so at the end of this link number 3, we have the big X and Y. Okay, so we can be given, or we can set what theta 1 is, what theta 2 is, theta 3, and then we can get the coordinate. So that will be the forward kinematics. So we know the location or the setting of the joints at the joints, and we'll get the n effector coordinate. Alternatively, for same here, if you have this information, So we can take this transformation matrix, plug in all the values of the theta 1, 2, and 3, and we can multiply it with this vector 2, 0, 1. So actually 2, 0 is this one. 2, 0. 2 is for x, 0 is for y, and 1 is for the z-axis or z coordinate. Okay, so here the n factor will be at 17.73 and 4.72. 73. Okay, so that is for kinematic. For inverse kinematics is the focus of our topic here, and this one is the one that will come out in the final exam. So again, a lot of this thing we consider in 2D. So 2D means x and y is the axis or axis. So in that case, the rotation is going to be about z-axis. Z-axis. So that's why. So you can look up in Wikipedia what is a rotation matrix or matrices, and if you rotate about z-axis, this is the transformation rotation matrix for rotation about z-axis. All right. So in this example, you have 5, 2 as the at the base of the robot. Then this small xy is at the wrist of the end effector. And the final point of the end factor will be the big X and Y. Okay, so this is the conclusion, how to calculate. So based on this figure, okay, and big XY will be at the very end of the end factor. So that is where the gripper wants to reach. Okay, and this is R3 or L3, R2 or L2, R1 or L1. And these are the angles. For theta 1 will be based on the horizontal line, but for theta 2 will be based on R1, and theta 3 will be based on R2. Okay, so that will be the reference lines. Okay, so you can calculate small x and small y, and then we calculate A, B, C. So this variable parameters are important for you to calculate very, very carefully. So their numbers are usually big, but you also need to maintain whether they are positive or negative numbers, because that ultimately will result on you picking which equation you want to use. Okay, so for theta 1 especially, if A is negative, so you use this bottom set. Okay, and you see in the second term here, you have a plus minus. So if you have enough time, you can choose both situation. So the first one, you use negative. So always use the one with the negative one. Okay, tangent inverse B over A minus cos inverse or a cos negative c over square root of a square plus b square, and then plus 180. Okay, so if you have enough time, you can calculate the next possible answer where you use plus here instead of negative. All right, so once you have calculated theta 1, you can go ahead and calculate theta 2, because in theta 2, we are going to also use theta 1, and theta 3 will be this one. So phi is going to be angle of uh, uh, the angle that is made by the final link 3. So phi will be the angle made by the absolute angle made by the final link. Okay, let's take a look at one example. This example. So we have the big X and Y. Big X and Y here, and use pen here for then it said so this is the gripper that needs to reach here, and that is the position, which is this one 396 628, and this is the gripper. All right, so if that is 30 degrees, meaning here is 30 degrees. Yeah, and this one will be angle P. What will this be? Smart about it. This one will be P will be 100. Okay, so understand why it is 150? Because this whole thing will be 180 degrees. So this one needs to be 150. Okay, so that's how you reason this whole thing. And in this question, we already know what the L1 or R1, R2, and R3. So we have to just use that information together with the fee that we have identified. And I think we can finish this off. But later we can definitely verify whether our answers are correct or not. Okay. So I'll keep that. So let's try to do this calculation. So I'm going to use this MATLAB to help me this calculation, but definitely you must try this calculator, hand calculator, so that we can finish it or solve this using in the test final exam. Definitely you cannot use this MATLAB. There's no access to MATLAB. Okay, so I have MATLAB already open, and let's put this on one side. This one, the next one. You get out of the way, and let's do this thing. So let's first identify what we are given or what we already know. So we know that P is 150. And R1 is 500, R2 300, and R3 250. What else do we know? In that problem, okay, so UV, if you look at that equation in the figure, U is at 0, as well as V is also at 0. Okay, then big X, we know that will be 396, 396.8547, and big Y will be 628, 638.5534, 5534. All right, let's use the equations. Okay, let's start solving for this thing. Okay, so X will be big X minus R3 times cosine phi. So cosine phi is going to be considered as the absolute phi. So we can calculate that. So I guess Y, big Y, R3 cosine. So this one is sine phi. Next, A, can calculate big A, 2 times R1 times U. Let's see, minus 2 times R1 times x. And d, I guess will be something similar, so I'm gonna copy that, paste. So instead of u, I use b here. Then instead of x, I have y. C is R1 square minus R2 square plus U square minus 2UX 2UX small x plus that with B square two times then plus that with x square plus that with y square. One, two, three, four, five, six, seven, eight. 1, 2, 3, 4, 5, 6, 7. So then next we calculate that one. One will be uh, in this case we have to check what is the we can give some instruction like if statement. So I can use that if a is if a is larger than or equals to 0. So delta 1 will be this that a tan b. So that will be b divided by a. So we're gonna use negative first a cos b minus q divided by cos q over t. A square plus b square. So the next one else will be this whole thing. So I'm gonna just copy that and paste. It's just that I need to add this 100 EP. So these are in degrees. And So that will let the program choose for itself whether it's top one, bottom one. So the next one is to calculate theta 2. So this is theta 2. Again, it can be the top one will be y minus v minus r1 times sine d theta 1. So that's the top part. We divide that by bottom part, which is x minus u minus r1 minus cosine of cosine. And then last one, theta 3 will be p minus theta 1 minus theta 2. And so let me try to run this. So this robot. Robot new. Uh, so here the values you can look over here on the left, bottom left hand side, and A is a negative value, so like that, and resulting values here will be theta 1 is 45, theta 2 is negative 15, whereas theta 3 is 120 degrees. So that uh, relates to this solution uh, that is selected. Yeah? In this solution, we see uh, This is theta 1. This is theta 1. This is theta 2. And this angle needs to be a negative because it goes from here to here. So that's a clockwise. So it's going to be a negative 15. And then this one will go counterclockwise. And the angle is 120 degrees. So this will be theta 3. Theta 3. So this is and then we can check the x will be 396 and the y will be 628. Okay, how do we know that uh, without, if you have no access to drawing, we can verify that, or verify. So that will be this one, u underscore, this is v. So that's the first vector, v. So then you take your R1 times the uh, that's the cosine theta 1. And then sine theta 1. Okay, then next one is theta 1 and theta 2. So the next one will be R2 here. This R2. One will be R2. R1. R2. This one will be P, 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 and run this thing. So if I look at the verify here, the verify, our verify is 396 and 628. So with this value, uh, we can manage to get this 396 point 8547, and this second one 628 0.5534, exactly as the input uh, for where the location of the bulb is. Okay, so that's the verification. Hope we can uh, try this and see if we can get the same solution using calculator. Okay, like I said, that is one possibility. We can also copy that and try to see if the next solution is this one. It's a positive one. Positive. This is positive. So what if we have this situation? Uh, the that are verify two, are verify one. Okay, so here we have the next answers. So the next answers will be this one. 393. Theta 1 is 393. And theta 2 is negative 344, 5. And theta 3 is 101. So even with these different answers, we can get we can verify to get to this same position. Okay, for the big X and big Y. Okay, I hope you understand what is being delivered in this lecture or this recording. And I hope you can understand. Should you still uh, feel blurry about this whole stuff, please contact me and and try to get your questions answered so that you will not regret during the test or during the examination. Because I remember when I was a student, I had one question about the matrix multiplication, and I hesitated to ask my professor because I thought that kind of question would not come out in the test. But I was so wrong, and that exact question came out in question number 1. So I hope you do not repeat my mistake. So whatever question that you still have, especially on this topic, make sure you ask me or you ask your friend first and get it ironed out or settled before the examination. With that, I wish you all the best on this question and other questions as well. And I'll see you when I see you. All the best for your final exam. Assalamu alaikum and have a good one.